Next chapter, compound proportions and rate of work. So far, we know about simple direct and inverse proportions involving two quantities. If an increase in one quantity results in a proportional increase in the other, that's direct proportion. If, for instance, you are contributing cash for a project, as the number of contributors increase, the total amount collected increases as well. And so the number of contributors and the total amount contributed are directly proportional. If, however, an increase in one quantity results into a decrease in the other, then the two quantities are inversely proportional. If 5 workers can finish a job in 10 days, an increase in the number of workers will result into a decrease in the number of days taken. And so the number of workers and the number of days taken are inversely proportional. If you can be able to identify the relationship between quantities like that, working questions here will be a lot easier. Let's take an example. 5 men can finish a job in 8 days. How long will it take 4 men to finish the same job? We have two methods for working this one out: the unitary method and the ratio method. The unitary method, this involves step-by-step computations. So we go, 5 men take 8 days. It means 1 man will take 5 times 8 days. And then 4 men will therefore take 5 times 8 over 4. And that gives us 10 days. The ratio method, the number of men decreases in the ratio 5 to 4. And so the number of days will increase in the ratio 4 to 5. And this is because the number of men and the number of days are inversely proportional. If one increases, the other decreases. So we have 5 over 4 is 8, and that gives us 10 days. But perhaps the biggest question usually is what fraction to multiply with. Why 5 over 4 and not 4 over 5? This is how we do it. We started by saying that you needed to identify the relationship between the quantities you are dealing with. Is it direct or inverse proportion? That's easy to know. Now consider a ratio like this: 5 to 2, which means a decrease, or 2 to 5, which means an increase. 2 and 5 can form two fractions, either 5 over 2 or 2 over 5. 5 over 2 is an improper fraction, and 2 over 5 is a proper fraction. When you multiply a number by an improper fraction, you increase that number. When you multiply that number by a proper fraction, you reduce that number. For example, let's take 10. 5 over 2 times 10 will give us 25. So 10 has been increased to 25 by multiplying it by an improper fraction, 5 over 2. 2 over 5 times 10 will give us 4, and so 10 has been reduced to 4 by multiplying it by a proper fraction, 2 over 5. For the purpose of this chapter, let us call an improper fraction an increasing fraction and a proper fraction a reducing fraction. And so in the ratio 2 to 7, 7 over 2 is an increasing fraction, 2 over 7 is a reducing fraction. And so in working proportions, all you need to ask yourself is whether you want to increase or reduce the other quantity. Let's see our example. We have two quantities, the number of men and the time taken to finish the job. 5 men take 8 days. How long will 4 men take? You ask yourself, if 5 men take 8 days, do you expect 4 men to take more time or less time? It's a simple common sense question. Of course they will take more days, and so we need to increase the other quantity. We use an increasing fraction. Between 5 and 4, the increasing fraction will be 5 over 4. So we multiply that with 8, and that gives us 10. Let us now rephrase the question. 5 men take 8 days to complete a job. How many men are needed to finish the same job in 10 days? In this case, the quantity we are looking for is the number of men. 5 men take 8 days. How about 10 days? You ask yourself, if 5 men take 8 days to complete the job, if you wanted to have the job done in 10 days, do you need more men or less men? Common sense will tell you that you need less men. More men will of course take less time. So if you want to take a longer time, you reduce the number of workers. So we want to reduce the other quantity. Between 8 and 10, the reducing fraction is 8 over 10. And so you multiply that with 5, and that gives us 4. Another example, a worker can finish a job in 9 days if she works for 4 hours per day. How many days will she take if she worked for 6 hours per day? Two quantities, number of days and the rate of working, that is in hours per day. 4 hours per day, she takes 9 days. She increases her rate of work to 6 hours per day. How long does that take? If she increases the rate of work, then surely she will take less time. And so we need to reduce the other quantity. Between 4 and 6, the reducing fraction is 4 over 6. And we multiply that by 9 and we get 6 days. Next, compound proportion. Now, in compound proportions, there are more than 2 quantities involved, and so the quantity in question will depend on at least 2 other quantities. For example, 5 men working for 4 hours per day are paid 2,000 shillings. What will be the wages of 10 men working for 3 hours per day? 3 quantities, number of men, hours of work, and the total wage. We work the exact same way, but we handle each pair of quantities separately. 5 men working for 4 hours are paid 2,000 shillings. 10 men working for 3 hours will get how much? So the missing quantity is wages. Compare each of the other quantities in relation to the wages. We start with the number of men and wages. At this point, we ignore the hours of work. If 5 men are paid 2,000 shillings, would 10 men be paid more or less? Of course it's more, so we need an increasing fraction. 10 over 5 times, leave it there. We deal with the hours of work and the wages. We ignore the number of men. If you work for 4 hours, you are paid 2,000. Suppose you work for 3 hours. Do you expect more or less pay? Of course you expect less. So we need a reducing fraction, 3 over 4. We multiply it here and then everything by 2,000 and we shall get 3,000 shillings. Another example, 40 workers take 5 days to dig a trench 90 meters long. What length will 25 workers dig in 12 days? 3 quantities, number of workers, time, and the length. 40 workers work for 5 days and dig 90 meters. 25 workers working for 12 days will dig what length? So the missing variable is length. We compare the number of workers versus length and we ignore time for a moment. 40 workers dig 90 meters. Will 25 workers dig more or less? Of course less. So we need a reducing fraction. 25 over 40. Now time versus length. We ignore the number of workers. For 5 days, they dig 90 meters. For 12 days, will they dig more or less? They will dig more, of course, and so we need an increasing fraction. Between 5 and 12, the increasing fraction is 12 over 5. We multiply that and then everything by 90 and we get 135 meters. Another example, a military camp has enough food to feed 180 soldiers for 30 days. How long will the food last if 20 more soldiers joined the camp? In this case, we have three quantities: amount of food, number of soldiers, and the number of days. However, we have no figures for the amount of food, and that's because it doesn't change. We can assign it any value, like 1. So we have the number of soldiers, number of days, and the amount of food. 180 soldiers will feed on that food for 30 days. 200 soldiers with the same amount of food will take how many days? Notice the fraction for amount of food is 1 over 1, so that doesn't change. If 180 soldiers feed on the food for 30 days, will 200 soldiers take less or more time? Of course less time. So we need a reducing fraction between 180 and 200. That is 180 over 200, and we multiply by 30 and we get 27 days. There are, however, some problems that will only work with the unitary method. For example, pipe A can fill a tank in 2 hours. Pipes B and C can empty the same tank in 5 hours and 6 hours respectively. A, starting with a full tank and A closed, find how long it will take B and C to empty the tank. B, starting with an empty tank with B closed, find how long it takes to fill the tank if A and C are opened. The only thing you need to find in such questions is the fraction of the work done per unit time. That is the fraction of the tank filled in 1 hour. A whole tank has a fraction of 1 over 1 or 10 over 10, 5 over 5, 30 over 30 or whatever fraction. A takes 2 hours to fill the tank. So in 1 hour, it will fill a half of the tank. B takes 5 hours to empty the tank. So in 1 hour, it will empty 1 over 5 of the tank. And C will empty 1 over 6 of the tank in 1 hour. And so A, if B empties 1 over 5 in 1 hour and C empties 1 over 6 in the same 1 hour, what fraction will they empty if they are combined? We simply add those two fractions. 1 over 5 plus 1 over 6 will give us 11 over 30. And so in 1 hour, they will empty 11 over 30. How long does it take them to empty 30 over 30? So 1 hour is equivalent to 11 over 30. How about 30 over 30? We do 30 over 30 times 30 over 11 times 1 hour. And that will give us 30 over 11 hours, which is equal to 2 and 8 over 11 hours. B, in 1 hour, A fills a half of the tank and C will empty 1 over 6. And so A works faster than C. What fraction will be filled in 1 hour if both were opened? It's the difference between the two fractions. So a half minus 1 over 6 will give us 1 over 3. So in 1 hour, a third of the tank will be filled. What about 3 over 3? So 1 hour is equivalent to a third. What about 3 over 3? So we do 3 over 3 times 3 over 1 times 1 hour, and we get 3 hours. Next, proportions in mixtures. Now, mixtures are formed by 2 or more different substances. In building construction, sand, ballast, and cement are mixed. In metals, alloys are formed by mixing 2 or more metals. The ratio of the components determines the quality and cost of the mixture. For example, an alloy is made up of 2 metals, A and B, in the ratio 1 to 3. The cost of 6 kilos of A is 5,400, and the cost of 3 kilos of B is 7,200. Calculate the cost of 8 kilos of the alloy. Now we find the cost per kilogram of each metal. A, 5,400 divided by 6, and that gives us 900. B, 7,200 divided by 3 will give us 2,400. Then we find the number of kilograms of each metal in the 8 kilograms of the alloy. We use the ratios. A, 1 over 4 times 8 will give us 2 kilograms. So the price will be 2 times 900, that will give us 1,800. B, 3 over 4 times 8 will give us 6 kilograms. So in the 8 kilogram alloy, there are 6 kilograms of B. And so the price will be 6 times 2,400, and that will give us 14,400. The total is 16,200. Another example, 2 brands of sugar A and B cost 25 shillings and 30 shillings per kilogram respectively. In what ratio should they be mixed in order to produce a mixture that will cost 28 shillings per kilogram? 2 things before we work this one out. 1. Consider a ratio like 3 to 4. We can actually simplify this ratio such that any of the elements, either 3 or 4, becomes 1. For instance, dividing by 3, we would have 1 to 4 over 3, and so the left hand side has become 1. Or dividing by 4, we shall have 3 over 4 to 1. In working proportions in mixtures, we find this fractional ratio by making any of the elements 1, and then we will find the whole number ratio after we are done. 2. The cost of the mixture is equal to the sum total of the individual components in the mixture. Let's begin. We don't know the ratio of the mixture, but let's make one of the elements in the ratio be 1 and give the other x. Any will do. So let's say A to B is equal to x to 1. Now we just need to find x, and if we get a fraction, we shall make it a whole number in the end. This ratio means that the mixture has x kilograms of brand A and 1 kilogram of brand B. And so the total mass is x plus 1 kilograms. Cost of the mixture is 28 shillings per kilogram, and so we shall have x plus 1 times 28. Separate costs. Brand A costs 25 shillings per kilogram. in the mixture we have X kilograms of brand A, and so we shall have X times 25, that is 25X shillings. B cost 30 shillings per kilogram, and in the mixture we have 1 kilogram of B according to our ratio, and so we shall have 1 times 30, which gives us 30. The total separate cost is 25X plus 30, and we have said the cost of the mixture is equal to the sum of the individual costs worked separately. And so X plus 1 times 28 should be equal to 25X plus 30. Opening the bracket, 28X plus 28 is equal to 25X plus 30. 3X is equal to 2, and X is equal to 2 over 3. Our ratio was A to B is equal to X to 1, and now we found X is 2 over 3, so we substitute it in the ratio. We have 2 over 3 to 1. We make it a whole number by multiplying everything by 3, and we shall have A to B is equal to 2 to 3. Another example, 2 brands of flour P and Q cost 120 shillings per kilogram and 180 shillings per kilogram. In what ratio should they be mixed in order to produce a mixture that will cost 140 shillings per kilogram? We choose a ratio with 1 and a random X. So we say P to Q is equal to X to 1. And so in this mixture, we have X kilograms of P and 1 kilogram of Q. Total mass will be X plus 1 kilograms. Total cost will be X plus 1 times 140. Separate costs, brand P will be X times 120 and brand Q will be 1 times 180. That gives us 120X plus 180. Cost of the mixture will be equal to the separate cost. And so we shall have X plus 1 times 140 should be equal to 120X plus 180. Opening the brackets, 140X plus 140 should be equal to 120X plus 180. 20X is equal to 40 and X is equal to 2. P to Q was equal to X to 1, and now we found X is 2, and so P to Q is equal to 2 to 1.
The way we teach it in university and in high school as well, and colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret, or the biggest piece of advice is get help early from as many people, and there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.